In section 4.3, we're going to be talking about multiplying and dividing monomials. So a monomial, it's a vocab word for us. A monomial is a number, a variable, or a product of numbers and or variables. Now notice there's no adding or subtracting. So if we look at examples, we have 80, we have just x, or we have 8 times x, 8x. So you see we have just a number, just a variable, or a product of numbers and or variables. So examples of not monomials, x plus 5 and x squared minus y squared. We cannot add or subtract. As soon as you see adding or subtracting, it is no longer a monomial. Okay, now we know what a monomial is. Our first key concept, our product of powers property. When we multiply powers with the same base, we add their exponents. So multiply powers with the same base by adding their exponents. An example right here for you. 2 to the 4th times 2 to the 3rd. You see that 2 and 2, we have the same base, equals 2 to the 4 plus 3. We're going to add our exponents, which gives us 2 to the 7th. So we want to find our products and express them using positive exponents. We worked with negative exponents yesterday, so hopefully you guys remember how to convert when you end up with a negative exponent. Our first example, 4 to the 3rd times 4 to the 5th. We'll see we have the same base of 4, must be same base. So we're going to add our exponents. So 4 to the 3 plus 5. You won't need to show this step, but for now I just want to make sure you understand what we're doing. And then 3 plus 5 gives us 4 to the 8th. And for now, we're just going to leave it right there. In our second example, 6 times 6 to the negative 4th. When you see just a number or a variable, remember your exponent is 1. So 6 to the 1 plus negative 4. Think about how we add positive and negative numbers. Would give us 6 to the negative 3. Now when we are working with our negative exponents, remember we want to think about the fraction. So negative exponent, we're going to shift it down to the denominator. So we end up with 1 over 6 to the positive 3. A little sticky note here for you, or watch out for this part. When you're multiplying powers, do not multiply the bases. Notice the bases stayed the same each time. We started with a 4, we ended with a 4. We started with a 6, we ended with a 6 in the denominator there. So bases do not get multiplied. Okay, so now a little bit of practice with some variables. Find each product expressed using positive exponents. So our first example, we're going to add. We have t to the negative 5th times t to the 3rd, same base, so we add the exponents. Negative 5 plus 3 gives us t to the negative 2. Think about that fraction again. Negative exponent bumps it to the denominator. We're left with 1 over t squared, or 1 over t to the 2nd. And in our next example, 2x to the 3rd times 8x to the 4th. So we see we have an x and we have an x. Those are our like bases. Now our unlike bases are 2 and our 8. Since they are unlike, we are going to actually multiply them. So 2 times 8 gives us 16. Then for our like bases, we add the exponents. So 16x to the 7th. So unlike bases, when they're numbers like that, you're going to actually multiply them. For our like bases, you add the exponents. So watch for like and unlike bases. All right, in 3C, we have 6x to the 3rd times negative 3x to the 5th. Just like that last one. We've got an x for our like bases. So x and x. And our unlike bases, we have 6 and negative 3. So 6 times negative 3 gives us negative 18. Add the exponent of our like basis, so 3 plus 5 gives us x to the 8th. And then our last one, 6b to the negative 4 times 2b to the second. So we've got unlike bases and like bases again. So 6 times 2 for our unlike bases gives us 12. We add negative 4 and 2, gives us b to the negative second. Negative 4 plus 2 is negative 2. Again, we have that negative exponent. So think about our fraction. The negative portion bumps to the denominator. 12 is not affected by that negative 2, so 12 stays in our numerator. So 12 over b to the second as our final answer. Alright, so there's some examples working with the product rule. So now we're going to talk about quotient. Quotient means to divide. If you haven't picked up on that vocab word yet, quotient means to divide. So we divide powers with the same base by subtracting their exponents. So our example here, 3 to the 6 divided by 3 to the second equals 3 to the 6 minus 2, which gives us 3 to the 4th. Our little watch out here. When dividing powers, remember that the denominator cannot equal 0. So for example, for 4b, which is not on this page, just keep in mind that your denominator cannot be 0. Okay, so find the quotient. 8 to the 5th over 8 to the 3rd. Like bases, must have like bases. So we could rewrite it to start off with as 8 to the 5 minus 3. 5 minus 3 gives us 8 squared. And just as a little side note here, the reason that this works, we could rewrite 8 to the 5th as 8 times 8 times 8 times 8 times 8 over 8 to the 3rd, so 8 times 8 times 8. So what happens? Our 8's cancel, and we're left with 8 times 8, which is the same as 8 squared, if you remember how our exponents work from section 1. Okay, so part C, 2 to the negative 2 over 2 to the second. Remember, must have like bases. We see, yes, we do have like bases, so we can work with our division rule. So 2 to the negative 2 minus 2, it's always numerator exponent minus denominator exponent. So 2 to the negative 2 minus 2, negative 2 minus 2 would give us 2 to the negative 4, not 0, negative 4. Got that negative exponent again, so think fraction. Left with 1 in our numerator over 2 to the 4th. Make sure you change that negative to a positive. We do not leave them as negative exponents unless the directions tell you that's what we're looking for. All right, part D, d to the 5th divided by d to the negative 2. Yes, we have like basis, so yes, we can do this. So d to the 5 minus negative 2. Remember how our subtraction works. Change to addition, change the next sign, so it's really 5 plus 2. Leaves us with d to the 7th. Nothing left to simplify, so that is our final answer. I have a little word problem for you here. Write and evaluate an expression for the following statement. The quotient of 10 to the 6th power and 10 squared. Okay, so let's see what we know about this. So 10 to the 6th power, 10 to the 6th power, would look like that. 10 squared be 10 to the second, and then quotient, we just said means to divide. So we want to rewrite this 10 to the quotient of 10 to the 6th, so we start with 10 to the 6th over, because we're dividing, 10 to the 2nd. So there's your writing part. So it asks for us to write. There's your writing part. Now we want to evaluate. So to evaluate this, okay, so we just learned that our division rule, we could rewrite it as 10 to the 6th minus 2. Well, 6 minus 2 is 10 to the 4th. And then since we are evaluating, we could actually figure this out. 10 to the fourth, 10 times 10, 10 times 10 gives us 1,000. Or unless if it specifies, you could have left it 10 to the fourth. So 10 to the fourth or 1,000. All right, a little bit more practice and this lesson's almost over. The table shows the approximate diameters of Earth, Mars, and Neptune. About how many times as great is Neptune's diameter than Earth's diameter? So to figure this out, looking at Neptune, looking at Earth, we want to know how many times greater. We're going to write a division problem. So 2 to the 15th divided by 2 to the 13th. Do our subtraction. We get 2 to the second. 2 to the second is 4, so 4 times bigger. 4 times bigger. 5a, about how many times as great is the diameter of Earth than the diameter of Mars? Okay, well, same idea. 2 to the 13th for Earth, divided by 2 to the 12th. 13 minus 12 gives us 2 to the first, which is just 2. So final answer, 2 times bigger. And last problem, the diameter of a small asteroid is 10 to the negative 1 kilometers. The diameter of Ceres is 10 to the 3rd kilometers. About how many times as great? Alright, so again, we are working with a division problem here. So we have 10 to the 3rd, our larger one, divided by 10 to the negative 1. So that's 10 to the 3 minus negative 1, which is 10 to the 4th. And we just discussed on the last page that that is 1,000. So 1,000 times bigger. Final answer. All right, there is our rules with multiplying and dividing.